That means that the simplest picture of the universe is a universe that's infinite. We really could live in a universe where there's galaxy after galaxy after galaxy in every direction.
That means the simplest picture of the universe is one that's infinite. We really could live in a universe where there's galaxy after galaxy in every direction, up, down, sideways, and it never stops. How big is the universe? Is it endless or infinite? What's its diameter? These questions have fascinated scientists for centuries, but thanks to the James Webb Telescope, we can now look back in time and explore the vastness of the cosmos to find some answers. There's something else out there, something beyond the galaxies we see, the visible matter. By peering billions of years into the past, the James Webb Telescope has given us glimpses into how the universe came into existence, shown us where it ends, and revealed what lies at its edge. But the discoveries made by this telescope have shocked scientists as they challenge some of the fundamental laws of physics. Let's explore the vastness of the cosmos, delving into its immense expanse and uncovering its boundless wonders. In the end, we've concluded that the universe isn't slowing down. It's actually speeding up in its expansion, which was a major surprise. The vastness of the universe is truly mind-boggling. The sun, that bright fiery orb lighting up our days and warming our planet, is actually quite far away. It sits at about 149.6 million kilometers, or 92.9 million miles, from us. To make it easier to grasp such distances, scientists came up with a unit called the astronomical unit, or AU, which is roughly equal to 149,598,000 kilometers, or 92,955,887 miles. Now, let's try to wrap our heads around the immense size of the entire universe. Scientists believe the universe stretches about 93 billion light-years across. But what exactly is a light-year? It's the distance that light can travel in 1 year, and a single light-year equals a staggering 63,000 astronomical units. When we consider that each light-year measures an incredible 9 trillion kilometers or 6 trillion miles, we start to grasp just how vast the universe truly is. But wait, there's more. The 93 billion light-years I just mentioned represent only the observable universe, the part our instruments and technologies can currently detect. Scientists believe the entire universe could be as much as 250 times larger than what we can currently perceive, meaning it might have a diameter of at least 7 trillion light-years. To truly appreciate this magnitude, think about traveling through space at the speed of light. Light zips through space at about 299,792 kilometers per second, or 186,282 miles per second. At this astonishing speed, light covers the distance from Earth to the Sun, 1 astronomical unit, in just 8 minutes and 20 seconds. To cross a single light year, light would travel roughly 9 trillion kilometers, or 6 trillion miles, over an entire year. Now imagine the space probes Voyager 1 and Voyager 2, launched back in 1977, which have traveled farther into the universe than any other human-made objects. They have now reached distances of about 23 billion kilometers, or 14 billion miles, from Earth. To put their achievement into perspective, let's compare the speed of the Voyager spacecraft to that of light. Voyager 1 is zooming through space at around 61,000 kilometers per hour, 38,000 miles per hour, while Voyager 2 maintains a slightly slower pace of approximately 55,000 kilometers per hour, 34,000 miles per hour. While these speeds sound impressive to us, they are actually just a tiny fraction of the speed of light, making their current progress quite small in comparison. Now, let's think about the challenge of reaching the nearest star system beyond our Sun, which is relatively close in cosmic terms. Proxima Centauri, a small red dwarf star, is located about 4.24 light-years away from our solar system. If we could travel at the incredible speed of light, it would take about 4.24 years to reach this neighboring star system. However, at the speed of the Voyager spacecraft, it would take an estimated 70,000 years to cover that same distance, making the difference between their velocity and that of light strikingly apparent and highlighting the vastness of the universe and the challenges of interstellar travel. As we delve deeper into space, we are greeted by enchanting constellations, the patterns of stars that adorn the night sky. These celestial artworks have fascinated humanity for centuries, guiding our eyes and sparking our imagination. One such awe-inspiring constellation is Hydra, the largest of the 88 recognized constellations, spanning over 100 degrees in the night sky and hosting a multitude of stars within its vast domain. Among them, the brightest is Alford, a splendid orange star approximately 177 light-years away. Just imagine the sheer scale of Hydra, its sprawling presence, and the countless stars within it, each holding a story of its own. Moving on, we encounter the captivating Centaurus constellation, renowned for its striking asterism known as the Southern Cross. Centaurus not only captivates the eye, but also harbors celestial wonders within its boundaries, system comprising Alpha Centauri, Alpha Centauri B, and Proxima Centauri. Alpha Centauri A and B elegantly orbit each other as a binary pair, while Proxima Centauri, about 4.24 light-years away, holds the title of our closest known stellar neighbor. While these stars may seem relatively near in cosmic terms, they still reside at immense distances, underscoring the grand scale at which celestial bodies exist. Continuing our celestial odyssey, we encounter the mythical Andromeda constellation, named after the legendary princess of Greek mythology. Within Andromeda lies the famed Andromeda Galaxy, also known as Messier 31 or M31, a colossal spiral galaxy located an astonishing 2.537 million light-years away. Spanning a majestic diameter of about 220,000 light-years, it is estimated to host a mind-blowing 1 trillion stars. Contemplating the sheer number of stars within a single galaxy fills us with wonder and reminds us of the unfathomable vastness of the cosmos. But let's not forget about our very own cosmic home, the Milky Way. Our splendid galaxy boasts a magnificent spiral structure stretching about 100,000 light-years in diameter. Its graceful arms fill with uncountable stars that twinkle and contribute to the splendid beauty gracing our night sky. Scientists estimate that the Milky Way is home to an astonishing 200 to 400 billion stars, numbers that are truly staggering and further emphasize the incomprehensible vastness of our galactic neighborhood. Venturing beyond the borders of our own galaxy, we encounter other major galaxies that populate the cosmos. One such gem is the Triangulum Galaxy, also known as Messier 33 or M33, the third largest member of the Local Group, a collection of galaxies that includes the Milky Way and the Andromeda Galaxy. Situated approximately 3 million light-years away, the Triangulum Galaxy spans a diameter of around 60,000 light-years and contains an estimated 40 billion stars, its delicate arms extending gracefully across the cosmic void, captivating astronomers and stargazers alike with its celestial poetry. Moving deeper into the universe, we come across the Whirlpool Galaxy, also known as Messier 51 or M51. This captivating beauty, located around 23 million light-years away, showcases a fascinating interaction between two galaxies, with spiral arms winding around companion galaxy in a mesmerizing dance of gravity. The Whirlpool Galaxy spans a remarkable 60,000 light-years and dazzles us with its radiant splendor. Another stunning sight is the Sombrero Galaxy, or Messier 104, situated approximately 29.3 million light-years away. This galaxy earned its name due to its resemblance to a wide-brimmed Mexican hat, with a diameter of about 50,000 light-years and a prominent central bulge surrounded by a distinct dust disk that gives it its unique appearance. Let's not forget about the magnificent Pinwheel Galaxy, also known as Messier 101, located around 21 million light-years from us. This spiral galaxy boasts an impressive diameter of 170,000 light-years, its spiral arms adorned with countless stars that create a captivating tapestry, beckoning us to explore its mysteries. These examples offer just a glimpse of the breathtaking galaxies that populate our universe. Countless others exist, each with its own distinctive characteristics, composition, and distance from us. Our universe is a vast and awe-inspiring place, brimming with cosmic wonders that surpass our wildest imaginations. As we gaze up at the night sky, we are reminded of our humble place within this grand tapestry of stars and galaxies. The sheer vastness of the cosmos humbles us, inspiring us to seek knowledge and marvel at the beauty that surrounds us. We are but tiny specks in the immense cosmic dance, witnesses to the magnificence that stretches across unimaginable distances. To put these distances into perspective, consider the speed of light, which travels at an astonishing 299,792 kilometers per second. As we've discussed, moving further, the star we Alpha encounter the Alpha Centauri star system is situated roughly 177 light years away, located approximately if we were able to travel at the speed of light away. It would take us even traveling at 177 years. It would still take us over 4 years. Can you imagine that? Alpha Centauri. You would spend nearly 2 centuries in transit. The Andromeda Galaxy resides on mind-boggling within a single constellation, 2.537 million light years, meaning that even at light speed, it would take us over 2.5 million years to reach this galaxy. To put that into perspective, consider that the entire existence of the human species spans roughly 200,000 years. Even at light speed, it would take more than 12 times the entirety of human history just to reach a single galaxy. Contemplating these vast distances, we realize that our cosmic neighborhood is but a tiny fraction of the universe. The observable universe is estimated to have a diameter of 93 billion light years, meaning even the farthest galaxies we can detect are still within this relatively small bubble of space. The immensity of the universe, with its countless galaxies, stars, and planets, truly transcends our comprehension. You may wonder why the universe is so incredibly vast. The answer lies in the fact that the universe is constantly expanding. In fact, it's expanding at a rate that surpasses even the speed of light. It's not that objects within the universe are moving away from each other, but rather that space itself is stretching and growing, a process that has been happening for roughly 14 billion years and continues to this day. As for why the universe is this large, we don't have a definitive answer. It's a question that baffles scientists and philosophers alike. Our perception plays a key role in how we grasp this immensity. Think about how small you are compared to an ant or an atom. The difference is enormous. Similarly, our perception of the universe is vastly limited, even in our modern age. In the past, our ancestors, without cars or planes, embarked on long, arduous journeys that took months or years. To them, Earth itself must have seemed impossibly vast. But with technological advancements, the world has become much smaller in our eyes, and we can now travel across the globe in hours or days. This shift in perception leads us to wonder, is the universe truly infinite? It's a question that has baffled scientists and philosophers and continues to ignite curiosity and debate. While we often hear that our universe is around 13.8 billion years old, its exact age remains uncertain. In fact, we sometimes struggle to determine the age of objects here on Earth, let alone across the vast expanse of the universe. Given the sheer number of stars and planets, the mind-boggling distances between them, and the fact that the universe is continuously expanding, the idea of an infinite universe does not seem far-fetched. Our perception often tricks us, making it hard to grasp the true nature of the universe. Looking at our world, we notice patterns of duality, day and night, hot and cold, love and hate, and everything in our everyday experience seems finite. So, imagining that the universe itself might be infinite isn't such a stretch. Many people are hesitant to accept the idea of infinity, as it challenges our everyday experiences. Yet even if we were to reach the supposed end of the universe, it would still feel infinite to us given its vastness and our limited understanding. So, does the universe have an end? Well, many cosmologists argue that the universe is flat and will continue expanding indefinitely. If the universe were positively curved, would the angles inside a triangle add up to more than 180 degrees? It would be finite in size. However, if the spatial geometry is flat, meaning the angles add up to exactly 180 degrees, then the universe could go on forever. When considering the end of the universe, one perspective suggests that galaxies and other celestial objects will keep moving away from each other, driven by the force of the initial Big Bang, implying that the universe will never reach a final conclusion or end. However, other theories propose alternative outcomes. One possibility is the so-called Big Freeze, where all the stars eventually burn out, leaving a dark, lifeless cosmic landscape. Another scenario, called the Big Crunch, envisions the universe's expansion halting, followed by a collapse that could lead to another Big Bang. The question of where space ends is difficult because space itself is constantly expanding. The Big Rip even suggests that dark energy could eventually tear apart vantage everything. Space appears to end about 93 billion light years away. While these scenarios are highly speculative and not expected for billions of years, this limit reflects only how far we can the depth of our curiosity about the true boundary of the universe. Whether the universe will last forever remains a mystery. It's possible that it will keep expanding indefinitely, But by the time any ultimate fate arrives, humanity may no longer exist to witness it. Our understanding of time, existence, and the universe's evolution becomes increasingly complex when considering such vast timescales. Many of the doomsday scenarios we imagine are perhaps a reflection of our own awareness of mortality and our longing to understand the cosmos. As everything in the universe is in constant motion, we observe galaxies moving away from us, a phenomenon known as the expansion of the universe, which suggests that space itself is stretching. Perhaps this endless expansion is a true end of the universe, a point where everything becomes so distant that it's beyond our reach, making the concept of the universe itself nearly indistinguishable. The fate and ultimate boundaries of the universe remain an unsolved enigma, and we are mere voyagers exploring and contemplating our place within this vast expanse. As humans, we are driven by curiosity and a desire to understand the world around us. Throughout history, we have made remarkable strides, from ancient civilizations observing the stars to modern telescopes and space probes. Yet every answer leads to new questions, pushing the boundaries of our knowledge. The concept of infinity is both fascinating and perplexing. We are used to beginnings and endings, birth and death, cycles and limits. So the notion of an infinite universe challenges our intuition. If the universe is indeed infinite, it would mean that its expanse has no bounds and will continue evolving, potentially giving rise to an infinite number of galaxies, stars, and planets. This idea is both awe-inspiring and humbling, as it suggests an unimaginable number of worlds, each with its own unique features and possibilities. Yet, the idea of infinity also raises profound scientific and philosophical questions. Can anything truly be infinite, and does it defy the laws of physics? These questions highlight the limits of our understanding and the vast mysteries still beyond our reach. Scientists and cosmologists have developed various theories about the universe's nature and fate, using observations, mathematical models, and our current grasp of fundamental forces. One prevailing theory is that dark energy will continue to drive the universe's expansion indefinitely, gradually pushing galaxies apart, burning out stars, and leaving behind a cold, empty expanse. Another theory envisions a cyclical universe, expanding and then contracting in an endless loop of big bangs and big crunches, suggesting a universe in constant renewal. As we continue to explore the cosmos, we gain more insights, but many profound questions remain open. No matter which theory proves true, one thing is certain. We have a long journey ahead before we can fully comprehend the ultimate destiny of our universe.